Today we are learning how to describe and characterize uniaxial minerals. Our goal is to determine a uniaxial mineral's optic sign, or whether it is optically positive or negative. Note that this is different from having positive or negative relief. Here's how we do that. Step 1. Find and center your grain. Switch to cross-polarized light. Step 2. Switch to the highest magnification and focus. Verify your grain choice. The best grains of the mineral of interest will have the lowest retardation. Step 3. Insert the Bertrand lens. On this microscope, it is a switch labeled BL above the cross polarizer. On many microscopes, you will also need to switch on a condensing lens here. This is the ideal image you will obtain. We call this the uniaxial optic axis interference figure. In a uniaxial mineral, you'll notice it resembles the shape of a cross. The arms of the cross are called isogyres. The center of the figure where the isogyres cross is where the optic axis is centered. This is called the melatope. Uniaxial minerals get their name because they have one optic axis. In all minerals, interference color bands circle the figure. Sometimes we don't see them because they are outside of our field of view in the microscope. These bands are called isochromes, and they increase in order from the center. Step 4. Note the interference colors in all 4 quadrants. In this example, all 4 quadrants are a first-order white. Step 5. Insert the accessory plate. Step 6. Observe the interference color changes. Here, the northeast and southwest quadrants went from white to blue when we inserted the accessory plate, and the northwest and southeast quadrants went from white to orange. Also note that the interference color of the isogyres is now a first-order magenta with the addition of the accessory plate. Step 7. Using the Michel-Levy chart, determine which quadrant exhibited the most significant increase in interference color with the addition of the accessory plate. The northwest exhibited a first-order orange, and the northeast exhibited a second-order blue. Step 8. Characterize the mineral as positive or negative based on these charts. If the mineral is uniaxial negative, the fast ray of the accessory plate will cause an increase in retardation and interference colors in the direction it is inserted. If the mineral is uniaxial positive, the fast ray of the accessory plate will cause a decrease or less of an increase in retardation and interference colors in the direction it is inserted. Since we saw more of an increase in the northeast-southwest quadrants, this mineral is uniaxial positive. More often than not, the melatope will be outside of your field of view, but you can still characterize the optic sign. In this example, we see one isogyre coming up through the center of our field of view. We need to rotate and reconstruct our quadrants in order to determine the optic sign. As I rotate, notice how the isogyres come in and out of the frame. As I rotate again, notice how I go through the northwest, into the southwest, over to the southeast, and up again to the northeast. This is a schematic of the view we currently have in our microscope. Again, I move from the northeast to the northwest. Then I insert my accessory plate and observe the changes. Watch as I rotate from the northwest, past the magenta isogyre into the northeast, and then rotate back into the northwest. This is the same uniaxial positive mineral that we observed before. Our interference color changes are the same, but our mineral grain is oriented differently. Now it's your turn to try an example. Here I go from plain polarized light to cross-polarized light. I've chosen a grain with low retardation. Then I switch to the highest objective, focus, and then put in my condensing lens and my Bertrand lens. Take a moment now to orient your quadrants. Now, I will insert the accessory plate. Take note of the interference color changes. So is this mineral uniaxial negative or uniaxial positive? Here are the charts for some help. If you answered uniaxial negative, you are correct. Here are some things to remember and some helpful tips. Try to find the lowest interference color and largest grain of your mineral for an interference figure. Most uniaxial interference figures are not perfect. Take your time to look for the right grain. Be patient finding the isogyres, and then again in orienting them. The reference circles provided are only for microscopes where a gypsum accessory plate is inserted from the southeast.